Hello again, everyone. Mr. Cruze here with another review for you. This time, the Trigonometry Chapter 4 test review. Remember, the topics that will be included on this test are angular and linear velocity, graphs of inverse circular functions, exact values of inverse circular functions, which is what we're going to start with here, and a few story problems involving inverse circular functions, which is actually not on this review. But if you've done the homework over the past couple days, I would suggest doing the odds in section 4.8 in your book, making sure that you can do any of those problems, and you should be okay. So let's just dive right in. Give the arc or value that correctly completes each of the following statements. Use exact values only. Big idea here, exact values only. Should be no decimals, radicals only. Leave things in fractions, things like that. So arctangent of 1, what you're finding is, what angle has a tangent of 1. The only thing is, this arctan, right? Arctan is between a certain quadrant, okay? It's between certain values. You'll remember, hopefully, that arc cosecant then, because sine and cosecant go together, and arctangent go between negative pi over 2 and pi over 2. Okay, so your answer is between those. And then, the others, arc cosine, arc secant, and arc cotangent, are all between 0 and pi. Okay? Very, very important that we make sure that we know the difference between those. Okay? So basically, you're looking for, between negative pi over 2 and pi over 2, which is essentially quadrants 1 and 4, what angle is the tangent 1? Well, obviously it's positive, so it has to be quadrant 1. So for this particular value, you can actually go to your table and look it up, right? So in quadrant 1, where's the tangent 1? Well, that happens at pi over 4. So my answer is pi over 4. Again, the temptation is to think, oh, well, tangent's also 1 at 5 pi over 4, but that is outside of your range there, all right? Number 8, arc cosecant of 2. So for what angle is the cosecant 2? Cosecant, again, arc cosecant is between negative pi over 2 and pi over 2. Obviously it's positive, so it has to be in quadrant 1. So the cosecant is 2 at pi over 6. And again, this is just straight from your table, right? This shouldn't be a huge deal here. Arc cosine of negative 1/2. Again, this is just another way to write the same thing, right? This is all the same stuff, it's just written a different way. So where's the cosine negative 1/2? Well, you'll notice arc cosine is between 0 and pi, quadrants 1 and 2. And for cosine to be negative, it has to be in quadrant 2. So what angle from your table has a cosine of negative 1/2? And that is 2 pi over 3. So hopefully these aren't too bad. These should be easy. Free points. Alright, sine of arc cosine of 1/2. This is an angle, okay? This is some angle, we'll call it theta if you want, that we're eventually going to take the sine of, but first we need to figure out what that angle is. So I need to know what angle has a cosine of 1/2. Obviously, again, quadrant 1 or 2, it's positive 1/2, so it must be quadrant 1. Cosine is 1/2 in quadrant 1 at pi over 3. So this now becomes sine of pi over 3. And then all you have to do now is look up, well, what is the sine of pi over 3? And that's radical 3 over 2. Hopefully these aren't too difficult. Alright? Now's where the fun begins. Cosine of arc sine of negative 1/4. So again, this is an angle that you're eventually going to take the cosine of. But you notice you go to your table and you look up negative 1/4, and on your table, sine is not negative 1/4. Not at a nice value anyway. So how do we deal with this particular question? This is the one where you draw a triangle to try and figure it out, alright? Again, arc sine is between quadrants 1 and 4, right? And it's negative, so it has to be quadrant 4. So here's our theta. Sine, in triangle terms, is opposite over hypotenuse, so opposite is 1, obviously negative because it's down below, and my hypotenuse is 4. A quick Pythagorean theorem tells me this will be 16 minus 1, so this is radical 15. Okay. And then they ask me, well, now I want to take the cosine of that particular angle. Notice I don't even need to figure out what that angle is. I'm just going to take the cosine. Well, cosine is adjacent over hypotenuse, so that'll be radical 15 over 4. By the way, it should make sense cosine's positive here because it's in quadrant 4. That's not so bad, hopefully. Arcsecant of 2 over radical 3. I looked at this one, and I looked at my chart, and I looked back at this one, and I was like, you know, I think this is basically one of the values on our chart. So I rewrote it, I rationalized the denominator, and this is, in fact, the same as arcsecant of 2 rad 3 over 3. It's just a clever way of rewriting it, right? So I looked that up, and secant is in fact 2 radical 3 in a couple 2 radical 3 over 3 in a couple of places. We just have to figure out what quadrant we're in. Well, arcsecant is between quadrants 1 and 2, but when is it positive? Quadrant 1. So I need to look what angle in quadrant 1 has a secant of 2 radical 3 over 3, and that is pi over 6. Neat. Alright. Sine of arcsine of 3/5 plus arcsine of 3/5. Now, this one's kind of an interesting question. You'll notice that this is an angle, call it A, and this is another angle. In fact, you'll notice it's the same angle, arcsine of 3/5 plus arcsine of 3/5. So this is actually A plus A, right? Or rather, isn't it sine of 2A? Sine of A plus A, sine of 2A. We have a nice little formula for that. And again, you'll be able to use your cheat sheet for this. It's 2 sine A cosine A. So really, all you have to do is draw one picture, because sine is obviously not 3/5 on your table anywhere. Positive, so it's quadrant 1. And here's our A. Sine was 3/5, so the opposite's 3. The hypotenuse is 5. A quick Pythagorean theorem will show this is 4. And now you can go ahead and fill things in. Sine of A is obviously 3/5. That's not bad. Cosine of A is 4/5. That's just from the triangle. And multiply it all out. Now, please be careful. I've seen way too many of you doing this. When you multiply by 2, you're just multiplying the numerator by 2, not the denominator. I've seen a lot of you doing that. Bad multiplication there. 2 times 3 times 4, that'll be 24. 5 times 5 is 25, so this will be 24 over 25. Easy enough so far. Alright, number 14. Cosine of arcsine of 1/2 plus arc cosine of radical 3 over 2. Once again, please notice this is an angle. And unfortunately, this time you'll notice it's a slightly different angle. At least it looks to be that way, right? It looks to be different, anywho. So we have a formula for that. Cosine of A plus B equals cosine A cosine B minus sine A sine B. Alright. Make sure you watch out for that sign difference as well. It's cosine of A plus B, but the minus is what's between them. So I need to draw my triangle. Arcsine is 1/2. So again, that's positive. 1, 2. Quick Pythagorean theorem will reveal this is radical 3. And you'll notice something. The cosine of radical 3 over 2, hey, that's the same angle, right? You could draw a second triangle if you wanted to, but it'd be the same triangle. So these are actually the same angles, so you could take a shortcut here if you'd like. But I'm just going to keep going along this path. The cosine of A is radical 3 over 2. The cosine of B happens to be the same thing. Minus sine of A, well, sine of A is 1/2, and sine of B happens to be the same thing. So this now becomes 3/4. Radical 3 times radical 3 is 3. 2 times 2 is 4. Minus 1/4, which gets you 2/4, which equals 1/2. Okay, and there's a couple other shortcuts you could have taken on that same problem. Alright, a couple more. Arc cotangent of cotangent of negative pi over 3. Notice this one is different than all the others we've done so far. This time the innermost part is just straight up cotangent of negative pi over 3. Okay, I can look that up on my table, in fact. Cotangent of negative pi over 3. Negative pi over 3, by the way, is coterminal with 5 pi over 3. So look up cotangent of 5 pi over 3, and you see that it is negative radical 3 over 3. So we're looking at the arc cotangent of negative radical 3 over 3. Now, here's the deal. Arc cotangent is in what quadrants? Well, arc cotangent is between quadrants 1, which is not obviously happening here because this is negative, can't be in quadrant 1, and 2. So it has to be quadrant 2. So I want to know what angle in quadrant 2 has a cotangent of negative radical 3 over 3. And that happens to be 2 pi over 3. Okay? Again, the temptation here is to want to put negative radical 3, but that won't work because cotangent's between 0 and pi. Alright. This is probably the last one for this particular video. So once again, you notice we're taking tangent of two different angles. This is an angle minus another angle, so A minus B. Okay? I'm going to switch to a different screen here just to give myself more room. Again, this is just two different angles, so we have an A and a B. And we're doing tangent of A minus B, and there is a formula for that, right? I believe it's tangent A minus tangent B over 1 plus tangent A times tangent B. Okay? Cool thing about this one is I really don't need to draw a triangle for either of these if I do it this way. You could do sine of A minus B over cosine of A minus B. As a matter of fact, when I made my answer key, that was how I did it. It's a little more work. You do have to draw the triangles and look for things. But if you just do it this way, you don't have to draw the triangles because the tangent's already given for you in both of them. You know the tangent of A is 4/3. You know the tangent of B is 8/15, right? And you're dividing by 1 plus those two multiplied together, 4/3 times 8/15. Only problem about doing it this way is you have to get some common denominators, which isn't so bad because the common denominator between 3 and 15 is 15. I only have to multiply the 4 over 3 by 5 over 5, so I get 20 over 15 minus 8 over 15 divided by 1 plus, and I just quickly multiply 32 over 45. Okay? So the top becomes, what, 12 over 15 divided by, I'm going to change the 1 to 45 over 45 plus 32 over 45, and I end up with 12 over 15 divided by 77 over 45. A quick keep flip change here. Keep the first fraction, flip the second, and change it to multiplication. You can do a little reducing if you'd like. 15 goes into itself once, 45 3 times, and this ends up being 36 over 77, which does not reduce any more than it already is. So our final answer for this one is 36 over 77. Okay? Alright, I think that'll do it for this video. We'll hopefully wrap this up in the next video. The next video will have graphs and the linear and angular velocity. Alright? Good luck studying. If at any time you have any questions, please tweet me, email me, or come in and see me in the morning. Alright? Good luck.